Hello, everyone. Welcome to Wednesday morning. Happy to. I'll have to help the next speakers. Okay, so we have a few announcements for you this Wednesday. The project has been asked to, if there's someone who can speak on LSST and your career for the Lunar and Planetary Institute. This is to an audience of families and general public. It would take place September 15th from 8 to 10 p.m. U.S. Central Time. And they would prefer if somebody could speak English and Spanish and do two versions of this presentation. If this sounds like something you might be interested in or somebody you know might be interested in this, please contact Rand Pal. It's rgill@lsst.org. Unconference sessions are happening this afternoon. So if you want to propose your topics, there's a board right out here. You write down something that you might want to talk about or get some feedback on or get other people's opinions on. You write that up on the board, then go and check that board throughout the day today and vote on things that you might be interested in discussing or participating in. All suggested options will have a place, so don't be shy. Even if 2 or 3 people come, you could still have a very interesting discussion and fruitful for the goals that you want out of that. So unconference sessions will be later today. Breakout slides. So all of the breakout sessions that you've been having throughout the week, the Friday plenary will be the time where somebody who is at that session will stand up and present a one-slide summary on what the main outcomes were from that session. So at this link here, is where the Google slide deck is. So at the moment, there are only 2 there, but we've already had a full day worth of breakout sessions. So if you're running a session, make sure to identify someone or yourself who's going to take notes and will be responsible for making that slide and presenting on Friday at the plenary, so the rest of us can benefit from the discussions that you've had throughout your breakouts. And finally, there is no official organized dinner tonight at the whole group level, but there is a junior members dinner. So if you're a non-tenured grad student or postdoc, you can meet tonight at 5:15 in the hotel lobby. If you want some say in what venue you actually eat at, then join the Slack channel. It's #JULO, which must stand for Junior LSST. Oh. So that's what's happening for dinner tonight. Otherwise, you're free to work on your Hubble proposals so that they're all done, and you can come to the public talk tomorrow night. Subtle, but true. Okay, so that's all the announcements. I am here for the next little while to talk to you about LSST education and public outreach. After I'm finished with my session, we'll do a round of lightning stories. So we have 7 very excited members of the project who are going to tell you a little bit about themselves, how they got into the project, what they do for LSST. And this was my favorite session at the Project and Community Workshop last year, so I'm very excited to bring this to you. And then finally, we'll have a bit more information about Storytime domain, which runs today and tomorrow, which you've heard about, but we want to give you a bit more information on that. Okay, so let me move this down a little bit. Education and public outreach. I'm the head of education and public outreach for LSST. I have an astronomy background. I got a PhD, I did some postdocs, and then my last position was at the Australian Astronomical Observatory, where I was the outreach officer in addition to research. So kind of officially got into the strategic thinking of what education and outreach can do. And LSST has this fantastic opportunity where they're funding the development of education and public outreach during the construction period, as opposed to sort of an ad hoc, if you're a scientist and you're interested in this, do it now. So that's a really fantastic opportunity. But within the LSST project, there is some confusion over communications and education and public outreach. So I want to start by clarifying this. Within the LSST construction project, communications and EPO are separate. As you can see, they're even separate teams. So on the left there, you've got people who some fraction of their time is dedicated to communications, led by Rand Pal Gill, and on the right, you've got the EPO team. So what is actually the distinction? Communications during construction is part of the project office, and their mission is to facilitate communications between the LSST project, its stakeholders, scientists, updates on construction progress, science opportunities, and other essential project information. So when you read a digest, or if you pay attention to the social media accounts that LSST has, that's all the communications team, that's not EPO. So some of communications responsibilities, they write and distribute updates, news. If we get any sort of media inquiries, they handle that. They do branding, they support conferences and reviews and town halls, AAS presence, SPIE, things like that. If you have a request, if you want swag for events, or you want some information about LSST, then you can use this communications-team at lsst.lsst.org email. And this will go to the communications team, and you will get a response much quicker than if you choose one individual person to try to send a message to. So for all your communications needs right now during construction, this is who you contact. As we start to ramp up to operations, that's when communications and EPO start to come together and start to be the main public face and form of communications. So once we hit operations, EPO and communications are together, we're one. During construction, we're separate. So the rest of the time for this talk, what I'll be talking about is actually EPO as a construction project. So we are funded through the National Science Foundation to build the infrastructure to do EPO once we actually have LSST data, once the telescope starts operating. So that's what I'll talk about the rest of the time. When I say things like the website, I mean the operations website for public, which is separate than what the construction website is. So education and public outreach. Our mission is to provide worldwide access to and context for LSST data through accessible and engaging online experiences so anyone can explore the universe and be part of the discovery process. We all, I think, have those essential moments where we had that like cosmic vertigo, wow, the universe is amazing, and maybe I could actually do that. Whether it's the Voyager launching, or you watched Curiosity landing on Mars, or you read Cosmos from Carl Sagan, or followed the Neil deGrasse Tyson revamp. These moments are the things that capture you. And while we're not launching anything into space, we have this opportunity of an amazing data set, time to build infrastructure, and think about how people want to interact with data, want to share things, especially in the present day and age. People see something clever or funny or inspirational, and they want to share it with their friends. So our task is really to help create those experiences, to guide that inspiration so people can have that moment and then also be able to share it with whatever social media happens to be around in 4 years from now. So during construction, the EPO project will build a whole list of things, and the rest of the talk I'll get into some more detail about these. We have a formal education program that's based on online notebooks. We'll build a website and materials that are both in English and Spanish. We have a repository of multimedia resources, so videos and photos, little snippets about the people who are working on the project and help build it and help do the science. We have an interactive sky viewer, so you can kind of zoom around and explore the LSST sky. A separate EPO data center from the main LSST data facility. The capability to build citizen science projects, so that's some of the infrastructure we're building now. We're working on the communications and marketing plan for operations. We have one set of stakeholders and audiences and our communication strategy during communications, and we'll have a whole separate thing, essentially a big marketing scheme when we go into operations. How do we let people know what it is that we're actually doing and building for them? And then the strategy for actually measuring success. Part of the challenge of EPO, especially in a construction project, is you set all of these very clear, this is what I'm going to build. Did I build that? Yep. Did I build that? Yep. Does it do what I thought it was going to do? And does it do the right thing? And so with EPO, it's a little bit more of a challenge to think about how do you know what's the right thing to build, and how do you measure whether it's getting the impact on people that you want. So part of the process of construction is us defining what are the outcomes that we want from our audiences. We define our audiences, we think about what kind of impact we want, and then we develop ways to actually measure that. So it's a interesting challenge that hasn't necessarily been solved, but we have the team to really make our best effort at this. Let's see. So who are the audiences for LSST EPO? We've identified 4 main audiences, and that's kind of who we build for, who we interact with to test some of the prototypes and products that we're building. So formal educators at the advanced middle school, high school, and college level. Citizen science principal investigators, so these are the people who want to start citizen science projects. The content developers at science centers and planetariums, and science-interested teens and adults. That's sort of a focus of the general public, big old bucket of people. And of course, these are the direct audiences. There are the indirect audiences, all the students who see activities that teachers bring into their classroom, or the citizen scientists who actually use some of the citizen science projects that scientists would initiate, and people who visit science centers. So those are our indirect audiences, but who we're kind of thinking that we're building for are the people who will take the materials to those people. So now going through some of the programs that we're actually developing. Formal education. Our formal education program is based on online notebooks. This example on the left is one of the kind of prototype Jupyter notebooks that we're using for one of our activities. The benefit of online notebooks for teachers, we had a whole user needs assessment period where we went out and talked to teachers, we talked to members of the public, asked them what kind of things they're interested in, what they would use. And having something for teachers that's accessible through a web page where they don't need to download, they don't have to have special software, they don't have to maintain that software, they don't have to get through firewalls, they don't have to download data. There are many teachers who are using the same set of data that they've had for 10 or more years because they have the software, it's their same version, they know it works. So for us to be able to maintain that stuff really opens what possibilities they have for bringing data into their classroom. We'll have embedded tools for data interaction. So you can see over here on the notebook, you've got what we're calling widgets. So there's an image of a sky, and then there's a plot on the right. And so in this particular widget, this is introducing the HR diagram. So the student gets some introduction. The teacher, by the way, has all of these support materials, a teacher guide, ways that these activities tie into the curriculum if they're in high school, if they're in Chile or in the US. And then this is the notebook that the student sees. So the student will read through the introduction. They might put in this activity, it's a cluster, so they get assigned a cluster, they put that in, and then the image shows that cluster. So what they do is interact with it. They use a lasso tool to identify where they think the cluster is, and then it automatically populates the HR diagram on the right. And so then maybe they circle interactively the main sequence. And then you can see the stars on the left that actually are part of the ones that they've highlighted in the HR diagram. So in this way, they can interact back and forth, and then they go through the rest of the activity asking questions. What are some of the hot stars? Why are some luminous? Why are not? There's little sliders under the plot that allow you to select what kinds of temperatures or luminosities you want to display in your plot. And so using that interactive tool, they go through and do the rest of the activity. Another benefit of this is, depending on what level you're teaching for or what you've already done in your classroom, you can modify any of this. So you can change the questions, you can change the difficulty level, you can do anything that you want. We kind of give you here's our recommended version out of the box. We've been doing testing, we feel like it's representative, but you can modify it as much as you want. So these are huge advantages for these activities. Here's another example of a widget. This one's called Coloring the Universe. This is a pretty early prototype. I'm showing you all our early prototypes. And I was going to do a live demo, but, plenary talk, that's dangerous. So we're not going to do that. But I will say we're having the EPO open house this afternoon just after lunch, and we'll be more than happy to go there if you want. But you'll also notice that we have a GitHub home for EPO. All of our stuff is open, so you can kind of go check out what we're doing anytime you want. So in this widget, what the students do, it doesn't come out quite so well here, but you have a selection at the bottom where you can select what object. We'll have types of objects, and then you can start to click on filters. You can assign a color to the filter, and then you can adjust contrast, and so you can slowly build up your own color image of various objects in the LSST sky. And so you can imagine an activity that we could take the public through or a student is maybe have a version of this where you get 2 display images next to each other, and you say, okay, open up this one astronomical image in, say, the G band, and adjust the black and white image, and open it up in the R band, or whatever band you want, and look at them and see what the difference is between the 2 filters. And it starts to introduce an astronomical intuition for why we might want to use the filters that we do, because it gives you different ideas of, oh, this star's brighter in this filter than it is in there, or there's a dust feature that comes out in this filter that doesn't come out there. So then you can start to give people natural intuition for why you might choose the filters, and then as you slowly add color and you build these up, you know why we choose the colors we do. You are able to understand why you might make the color image that you want to make. You can see this going into the artistic realm, but also into the artistic realm, and it kind of starts to get people away from the idea of false color, that we're just kind of making things up with the sky. But we're assigning colors to things that we can't see with our eye for very good reasons, and so bringing them along in that journey. So these are two examples of things we've been working on. The formal education program has 6 main themes. I've shown you so far the properties of stars. That's where the HR diagram investigation is. Properties of light is where that coloring the universe investigation is. And then the other 4 tie into the main LSST pillars. Each one will have that foundational investigation and then probably some extension exercises that go in a little bit deeper into that particular topic. Again, these are things that we're working on prototypes. Once we develop them, we put them in front of teachers, we put them in front of students, get them to play with them, understand how they might use them in their classroom, what we've done well, what we haven't done well. And so we can iteratively better the design so that it's more useful for people in their classroom. And these will officially be active once we move into operations. Right now, we're having to use precursor data because LSST data doesn't exist yet. So we're using other data that exists to populate these as we start to get commissioning data, and then eventually the DR1, that's what will be populating these activities. Okay, moving away from formal education into the multimedia gallery. This is actually something that you can access right now. If you go to gallery.lsst.org, or you can get to it through the LSST homepage, you go into this system where we're regularly updating construction photos from the camera, from the site, from the various places where telescope parts are being constructed around the world, and following them as they go all the way down to Chile. So you can use this resource right now. What we're doing in EPO is also developing some other strategic things that will be used in operations. Videos capturing that construction process, telling the story of what LSST is, talking about who the people are who are part of that construction process. It's not just PhD astronomers, it's anywhere from all kinds of software, engineers, optics, lots of different skills go into the process of building this. And we're trying to capture those things and get some video footage of, black holes and galaxies and exoplanets and all those other kinds of science topics that might be interesting for, in particular, science centers or planetariums, people who are building the shows there. The Sky Viewer. So you've kind of seen different versions of this where you populate it with the images of LSST and the public can zoom around and they can click on objects and get some more information. One of our first prototypes of this we put in front of an audience, potential audience members, and they said, well, it looks nice, but what do you do? For an astronomer, it makes a lot of sense. We know we have things that we want to do with it, but for the general public, there was nowhere to go. And so that got us thinking about these ideas about having kind of curated sets of objects, almost in a BuzzFeed-like way, the top 10 most exciting galaxies that LSST has discovered, and things like that to give people a path where they go. It really gets their attention, and it tells a story of what LSST is doing. So it kind of guides them through. And so in this way, you highlight different objects that are in their field of view, and you give them closer images, and it just offers them a path for exploration. So some of the quotes that we've had so far from people we've tested with, there was a lot of information about something that's so intangible, and an exploratory site where you get to just delve into what the telescope sees. So these are promising developments, still all prototypes. Something I'll mention is that the website will be mobile friendly. Oh, sorry about that. Most people who are our audiences are not going to go to their house and sit down with their laptop and be like, all right, LSST. This is not going to happen. They are going to be on their mobile device. They're going to see a link through social media. They're going to kind of click through a news story, something like that. That's how they're going to find our site. So it has to be accessible to them in that frame. So this is really important, and responsiveness is also important. People, astronomers might have a little bit of patience to sit and wait for a query to go through and give them results. The public, no way. If it takes 4 seconds, they're off, and they're never going to come back. So responsiveness is really important. The interface is very important for our audiences. I mean, of course you all have high standards, but the public is much more tricky, particular, shall we say. So citizen science. This is something that we're very excited about. I think I see citizen science, this is a people-powered research. If you haven't heard about it before, it's getting citizens to go in and help with science questions, looking at images, looking at data, and classifying things, or giving you the answer that you're asking for. A good combination between machine learning and human eye sensitivity is the best combination to get some of the results. We still do better with our eyes at identifying faint things or asymmetrical features. So citizen science is a really powerful tool, in my opinion, it's a research tool to enable more science to be done with LSST data. So what our role is with EPO and LSST is to enable researchers to initiate citizen science projects. The standard way that you do it right now with one of the more popular tools is a screenshot of Zooniverse. What you would do now is you would go into their project builder, you would upload data that you happen to have on your disk somewhere, and then you would build the tool that way. But that's not practical at all in the age of LSST. So what we're doing is building the infrastructure to make that process a lot more smooth. We're partnering with Zooniverse because they already have this project builder tool. They've got that infrastructure. They've got 10 years worth of experience of what works and what doesn't for maximizing science out of citizen science projects. And so here's an example of a project that exists now. This is called spacewarps.org, and they use LSST-like data. They actually use the HSC data that's been reduced with the LSST stack. So you can go and see kind of what this might look like, what LSST data might look like in this project. And they've had lots of results coming through this project that's live now. So feel free to check that out. This is led by Aprajita Verma, who's at Oxford. So what we're doing is taking this project builder infrastructure and making it possible for you as a scientist to go into the science platform that DM is brilliantly building, select your survey, the sample that you want to do, and then have that go straight from there into the project builder so that when you go to the Zooniverse project builder tool, you have a selection menu or some token identified way to get back to the sample that you've already identified, and you can open it up in here, and you can then have citizen scientists classify all the things for you. So we're working now to build that infrastructure to make it easy as possible for you to use any kind of LSST data to build a citizen science project. Another thing that we're introducing to citizen science that doesn't exist right now is the ability to build projects in languages other than English through the project builder tool. So we're supporting the Zooniverse to be able to build projects in Spanish in particular, or any project that's built in English. You can go in with translators and translate that into quite a few languages. So when we've done polls and surveys in Chile, not very many people that we've talked to have even heard of citizen science, and part of that is most citizen science projects are in English. They're not available in Spanish, and so they're not accessible to that audience. So that's something that we're working really hard. There's no reason why it can't be other languages in addition to Spanish, but those are the two that we're really focusing on. So Spanish language is a very important aspect of our program because the telescope is in Chile. There are fabulous efforts through AURA organizations and EPO, and most of them are within the local La Serena, Coquimbo area, right around where Cerro Pachón, Cerro Tololo are. So we're working with those people, learning lessons, understanding what they're doing, but what we're offering in our online notebook setting for formal education offers something completely unique to Chile, something that all the way across the country they can access. That's a very exciting part of our program. Why that's important, that the things that we're building are not only in English but also in Spanish, is that a recent census showed that only 9.5% of Chileans can actually have a conversation in English. So if we just present all of our outreach materials in English, most citizens can't access that. And there's such a huge amount of Spanish speakers around the world that we really want to emphasize this. So we're developing things and we're translating it into Spanish, but it's more than just a translation. We have an EPO Chile coordinator, her name's Claudia Arrea, and you actually hear from her a little bit later, based in Santiago, and she's been working with educators across the country to really understand what internet accessibility is like, what kind of devices people use in their classroom. Are they using tablets or Chromebooks or laptops? Is there one laptop per classroom? If that, do they use laboratories? So just kind of understanding what people have available to them, in addition to the curriculum standards and things that they teach to within Chile. So it's more than just a translation. It's very specific to the Chilean population. But again, there's no reason why the things that we're developing can't be translated into other languages. I know we've got very eager French collaborators who want to help with that. Diversity, inclusion, accessibility, it's really important to us to make sure that we are engaging with diverse learners and those traditionally underrepresented in STEM to ensure that the things we're building are relevant, are accessible, are interesting, are engaging, and they continue to be over time. One of the things that's a challenge for us is we don't go live for 3 years. That's ages in internet time. So making sure that we are updating things and using them and following along with what the trends are and what people are actually interested in doing for a broad set of audiences is something that we're working on. How are we doing that? We're doing continual user testing. I've mentioned this a little bit. So far, we've talked to 168 people in 27 different US states, in Chile, in the UK, showed them prototypes, gotten their feedback on things that we're thinking about building or that we have built, and understanding how they would use them. We've tried to recruit for a diverse group of individuals in order to do this testing, and it is really amazing how much insight it provides. Our EPO team is so unique in that we've got expertise in so many different areas. We've got an education specialist, we've got someone in Chile, we've got an astronomer, we've got a lot of developers. All these people come together and have really great ideas, but when you put things in front of people and get their feedback, it's amazing what kind of things you just didn't think about when you're so close to the project. So this has really helped inform some of our design process and some of the decisions that we've made, and we will continue this user testing in order to validate the program that we're building. So by the time we get to operations and we're ready to officially launch, we've tested with people all along, so we know what's successful and we know what's working. So finally, to round out, engaging with the LSST community, this is a very important thing. We are in the process of designing and developing a lot of these programs right now, but we definitely want to work with people to understand what's important to you that LSST does to represent LSST to the public. So things like writing articles about your favorite science topics can help populate the website as we're working on it. Precursor data into our data center to help populate some of the formal education activities and other things that I've talked about. Contributing object selection algorithms. I know some work is being done in science collaboration, so we'd love to be able to tie into that expertise on an agreed upon way. Developing interactive visualizations if you have some ideas for these things or you want to help develop. Working with the education team. One thing I didn't mention is all of our educational activities will have professional development going along with it to really empower teachers to feel confident to bring these tools and bring these activities into their classroom. So not only the content, but the tool training. And we'd like to work with scientists to maybe have mentorships or regional people that teachers can reach out to, or even if you want to go into classrooms and give presentations or work through some of these notebooks on your own. We'd love to build those networks. Prototyping citizen science projects. You'll hear from us. We've already talked to a couple people in the audience even about ideas for citizen science projects that they might have. And so we'll be working through this workflow to make sure the data can flow and that we've got everything working. It's kind of our commissioning process. So over the next couple years, as you have ideas or and want to talk about anything, reach out to us. A good way is through community.lsst.org if you're not already a part of that, or Slack or email. And then stopping by the Storytime domain booth. It's open today, it's open tomorrow here. So part of what we want to do is capture those stories. If we have an article on something about solar system science result, we would love to have a feature of somebody who's working on that or somebody who helped develop the algorithms that identified those things. So putting the personal story along with some of the results that LSST will be cranking out in the future is something that's really important to us that I think the public will connect with. So by participating in that, you really help us in that effort. What to expect this week from EPO? Storytime domain, I'll say it just one more time, is all day today, all day tomorrow. Kristen will tell you a little bit more about that later this morning. Communications office update, just after tea this morning, you'll get the communications office. That's run by Rand Gill and the communications team. Today after lunch, we'll have the EPO open house. So I encourage anybody to come if you're interested in talking about any of these topics or seeing a live demo. And then tomorrow night is the public talk. That will be by Phil Marshall and Artis Harold. Artis is the education specialist of the EPO team. So you'll get a whole different perspective about what EPO is presenting through Artis tomorrow. So I encourage you to go to that. We will have a little bit of time right now for questions. But I want to invite everyone to go to this website, pollev.com/LSST. It'll be open today through the EPO open house to give us some feedback. Let us know, what would you like to know about LSST EPO? What did I say today that was particularly interesting or particularly worrying? Any of those things are fair. How would you like to get involved? We will collect these answers. It'll help us know what to talk about in the open house this afternoon, and it just informs us about how we can get involved with the community. So I welcome you to go to that. That's my summary. So I'll leave that up so you can feel free to do that, and then we'll open things to questions. So thank you very much for your time. For questions today, I would like to encourage anyone to ask questions, even if you don't typically ask questions. We've got some runners with microphones. If you want to raise your hand. They're happy to go to you.
So you made the point that the world of the internet moves extremely quickly in 3 years. Mm-hmm. And so are you worried about the fact that platforms will change dramatically in 3 years? Instagram will be, last year, or are you thinking more about sort of the content and the kind of things that people are thinking about, or what? I wonder if you could say a little bit more about that.
Yeah, all of those things. Uh-huh. We have built into our plan refreshes on the content that we develop, even small things like the shape of the button that you click to go places. There are fads that come and go in web design, and so kind of staying up to date with those. You bring up the whole social media realm. I'm not making decisions right now. That's something that we're going to be thinking about and monitoring. We have accounts on some of the main hotspot social media right now just to kind of maintain following and build that up. But we'll keep monitoring that and making sure we follow some of the trends at a reasonable way that we can actually resource with humans around there. And then also platform, absolutely. Jupyter Notebooks, there's a big team of developers right now working on that, but at the moment it's still a little bit in early days for it to be easily modifiable for the public audience. So that's something that probably in the next 2 years, it'll be a lot easier for us to work with that. And so in the meantime, we're doing some HTML development, things that we have more control over. So we're definitely watching those aspects.
It's pretty easy to get, let's say, view counts on a website or something. Is there a plan how impact of these Jupyter notebooks, let's say, will be evaluated if they are used in classrooms? If they're not, how big of an impact do they have?
Yeah, great question. So for those, of course, we're collecting just regular web analytics. Teachers are going to have to log in order to access those, and so we can ask teachers periodic questions about the kinds of school districts that they're in, the number of students that they're presenting to, if they use more than one notebook, how far they go, what we can survey them over time to ask them what they feel like their success rate was. In addition to the user testing that we're doing now, we're building up a network of teachers that we have relationships with to talk with them about how they're using it and are they spreading the word, and do they want to use 2 or 3 different activities throughout the course of the year, or did it not work for them? So there's lots of different ways, in addition to analytics, actually surveying and following our users to understand the use cases. Got one up in the front, and one back there. Jeff, do you want to come up here with your mic?
Okay, can I ask? So is everything you're talking about going to be available worldwide, or is some of it restricted by data access policies?
Good question. Everything in the EPO data center is world public. So anybody can access it. The audiences that we're thinking about are particularly the US and Chile, with things like if our formal education activities tie into curriculum that US schools are already calling standards. So we're making that connection specifically for the US and Chile, and we're not doing that worldwide. But anybody can access what we're developing.
When will be the first teacher-focused presence at the project and community workshops?
Oh, great question. I don't know. At the public lecture tonight, I believe there's going to be a lot of teachers who are pretty interested in what Artis has worked up. But that's a really great question. I think maybe next year will be too soon, but maybe the year after that we can start thinking about that. Thanks for that. Okay. Any last one?
Do you have a specific focus in terms of grades and level of education that you are thinking about? Or what is the range?
Yeah, so we're focusing on kind of the advanced middle school, high school, college intro classes. Certainly people can modify them to increase or decrease the difficulty level, but that's the age range that we're focusing on. When we've done our user needs assessment, those were the age ranges where there weren't activities like this available to teachers, that we really had a place to fit in to fill a need that we found within the teachers. So those are the ones we're focusing on. Okay, well, thank you very much for your interest. Where's Meredith? Oh, there she is. Hi, Meredith. Do you want to come over here and get your mic set up? Okay, so it is my absolute pleasure to introduce some Lightning Stories speaker for this year's LSST 2018. We have 7 members who have representation across the project, who will all get up and speak to you for a few minutes. Their names are, are you gonna, can you swap the? Done. I froze that. Okay. I'm being behind the scenes, don't worry. Okay. Well, I have a list of names, eventually, that will pop up here. And our first speaker is Meredith Rawls. So one thing that really thrills me about this is it's hints of the reasoning behind Lightning Stories is we have limited amounts of time to have plenary sessions, and you typically get kind of the same voices and the same people up talking to you to summarize things. And so there are so many people who contribute absolutely wonderful things to the project that we don't have the chance to see and get exposed to or talk to in our regular everyday working environment. So we'd like to highlight some of those people here through Lightning Stories, and the first one is Meredith Rawls. So thank you very much.
Is this working? There we go. That sounds promising. And do I have a clicker? Okay. Thank you so much. All right, good morning. So people often ask me, what are you most excited about for LSST? So I work on the data management group. I do a lot of software stuff. But when I think about the project as a whole, the thing that I'm most excited about is the discoveries that we're not even expecting yet. And in a lot of ways, this has some similarities with my career so far. So I got my undergraduate degree from Harvey Mudd College, and then I did a master's degree at San Diego State University. Then I applied to grad school a second time because it wasn't fun enough the first time, and I did a PhD at New Mexico State University, and I finally graduated a couple years ago. And then I wasn't entirely sure what I was going to do, but I managed to find a position at the University of Washington working on the data management team here at LSST, and it has been an excellent way to combine my expertise in astronomy research with kind of my new up-and-coming skills in software development. So that's kind of my trajectory so far. So if I had to sum up what I do for LSST in a single sentence, which we were instructed to attempt to do, I would say that I create software that will turn snapshots into science in real time, which is something that you probably have heard about in terms of, LSST's, we're going to take a ton of pictures. You probably know that if you're here at this conference. And the goal is to get a lot of really cool science out of it. And there's a lot of software that we're currently working on building that is going to be responsible for doing that. So, okay, but I obviously, single-handedly, I am not doing all of this, so what part of it am I actually involved in? My work is part of the alert production pipeline. So, briefly, we have a whole bunch of different processing steps where we take a snapshot at the telescope, and then at the end of about a minute, we have to be able to turn that snapshot into something that we can send out to the community at large and say, we found something cool that changed in this image compared to a past image. And each step along the way is being developed by a lot of my colleagues who've done a ton of work figuring out how to characterize the image, how to subtract a new image from a previous image to see if anything has changed. And what I'm working on is stitching these steps together so that we have a way that we can run a data set of images that exist right now from obviously a different telescope through this set of processing steps and figure out at the end of the day, did we find a bunch of stuff that was actually real and changing, or do we need to kind of go back and tweak different parts of the process to get a better result? So here's a little very in progress example of the kind of thing that we're getting right now. On the right there is a source that we saw at one point in time, and then another point in time later. And below it, that little wiggly graph is how the brightness of that particular object changed with time. Now, there's a few issues with this object. There's some stripe nonsense going on there, some artifacts we need to kind of resolve still. So this is very much a work in progress. But the idea is that at the end of this will all happen automatically. We'll be able to run the pipeline on the images that come in from the telescope, and we'll get a big database of all the interesting things that have changed and be ready to go for science. So to conclude, I wanted to kind of put up a big pile of snapshots that highlight some of the last couple of years, what I've been working with LSST, doing a bunch of different things. Up in the upper left there, you can see some office shenanigans, including some chair races and some fun social times in our communal office area. Sitting at my actual desk, doing some actual work, occasionally happens. And then down in the corner, in the bottom left, you can see me actually looking through a telescope, which, again, occasionally does happen. I also got to organize a science communication conference for a bunch of graduate students last year in Seattle that went off very well. I got to visit Harvard and stand in front of a big picture of the sun, which was always fun. And I've gone to a couple different conferences, bringing a space turtle along for the fun of it. And of course, the center of my universe is also my husband and daughter, who are also here for the week. So if you see us around, feel free to say hello. Thanks so much.
Okay, next up we have Brian Stelter. Take it away.
Thank you. Brian Stelter, commissioning scientist for LSST. I joined the project exactly a week ago, or sorry, a year ago this week. And I just threw this together, yeah. My background's in observational astronomy, and quite varied, both professionally and personally. So I just wanted to illustrate, if anyone wants to talk about aviation, country music, selling T-shirts on the road, or going to Antarctica, come and see me. But in astronomy, I just want to say I've designed, built, and commissioned several projects over the years, going back even to the mid-90s. Sorry, I don't have any pictures from those dark ages, where a team of junior college students built a microsatellite, and my particular subsystem was the attitude determination and control system of that satellite, and it eventually was used to verify the long-range antenna for the Mars Pathfinder, so I got to work on that project as well. Then in grad school, I worked on a project that many of you know, PanSTARRS, in the camera lab, commissioning the microcam, kind of a comm cam for PanSTARRS. And then after that, I went off to Harvard and worked on the South Pole Telescope, a balloon-borne project called the Stratospheric Terahertz Observatory, which is a balloon project out of Antarctica, and then a camera that eventually went on to Magellan, is in operation now, called PSCO. And then I went back to Hawaii and commissioned two twin 50-centimeter telescopes called Atlas. So for LSST, what I've been doing for the last year is concerning system verification and science validation. In other words, does the LSST system work as specified and designed, and does it meet the science requirements? And because the commissioning team doesn't have any real formal hardware deliverables, we've been mostly in the planning stages. But I am also doing support of the subsystems particularly the ComCam effort, where I'm advising the two teams on the camera and the telescope and sight sides, with the intention that we're going to be assembling and integrating it on the telescope in 2020. And then another system that I've been trying to build up is something called the Environmental Awareness System, and that's to basically pull together all the sensors around the summit area and be able to configure and optimize the LSST system to those sensors and that information. And I think I just have one more slide, and I'd just like to say over the last year, it's been a real exciting adventure getting to work with all these teams in various capacities, and I'm looking forward to putting it all together and getting to see how great this historic system is going to perform. So, thanks.
Okay, next up. Yeah. Oh, you have a pocket. Excellent. Next up, we have Diane Haskell.
Hello, my name is Diane Haskell, and this is my story. There we go. First, a little bit about me. I graduated from UC Davis in June of 2014 with my Bachelor's of Science in Mechanical Engineering. In December, later that year, I started working on the LSST camera at SLAC, where I sometimes get to look at pretty cool schematics. A few fun facts about me that are completely unrelated to anything else. I am totally a cat person. I have lived with cats essentially my entire life, and they are pretty great. I'm also rather fond of making art. I like doing that in my spare time, and I've completed a total of 13 sketchbooks so far. And I can deadlift 100 pounds. But now for some more relevant information. What do I actually do for LSST? Well, I do refrigeration system operation, design work, paperwork, assembly and testing, and anything in between. I've worked for 3 different subsystems since starting at SLAC 3.5 years ago, and sometimes what I end up doing is pretty much anything that needs to be done to move the project forward. This could mean helping with requirements documents, or it could mean getting to turn wrenches with the technicians. One thing in particular that I've gotten to work on this year that was pretty cool was the Cryostat Mock-Up. This is essentially a bare bones version of the actual cryostat that we were going to use to test the installation and removal procedure for the rafts, because those are very expensive, and we want to make sure that when we put them in or take them out, we don't break anything. I inherited a partially completed design, and it was my job to finish the design, do the drawings, procure all the parts, which you can see a bunch of the pictures of, assemble everything, and then run metrology on the final assembly. The metrology ended up being one of the most difficult parts of the assembly. The actual cryostat has some very tight tolerances, and we had to match those in order to make sure we could actually install the rafts correctly. But we don't necessarily have all the same interfaces, so trying to tap parts into place so they lined up just so, when the software you're using to run metrology sometimes loses track of where your hardware is, was definitely quite a challenge. One thing in particular that I loved about working on this was being able to see these components go from the screen to real life. In particular, I had these 3 assembly stages modeled up, and getting to do a one-to-one comparison between the 3D CAD models and the actual physical hardware was really cool. And then once we finally got everything assembled, we were able to install it in our test fixture and actually use it, and this was a huge milestone. At this point, we were able to do several weeks of installation testing and get a much better understanding of how to actually do these installation procedures. And I'm really proud of just how useful the mock-up ended up being. But I wasn't quite done having fun with the mock-up at that point. Inspired by our wonderful LSST Lego minifigures, I decided to do some Lego modeling. I made a Lego model of the Cryostat Mock-Up, and I installed it in a Lego model of our test stand. And yes, this mock-up can also hold rafts. Thank you.
Awesome. And I've enjoyed watching all of the photos come in of the progress of the camera. It's really amazing. Here you go. You turned on?
Yes.
Yep. Okay. Next up, oh, you want to forward your slide? We have Seb Bungar.
Good morning. So yes, I'm Seb. I go by a longer given name, but Seb will do probably. I work in Paris, but I actually live in France, in Autun, a beautiful city that was built 2,000 years ago by Augustus the Emperor in order to lure the Gauls from their stronghold using all the benefits of Roman civilization. And I think that plumbing was the thing that made the trick. Over there, I brew meat and beer, tend to animals, split wood, cure meat, and all in all, spend my time having a happy family life, which hardly leaves me enough time for Aikido and no time at all to paint what I love to paint, miniatures. So sorry, no fun fact about myself. On the other hand, I was asked to tell you about frustration, and we need to talk. Really. I let it as an exercise for the reader to figure out, using facts, what happens when the sun directly shines on a mirror of the side of LSST. So I take the opportunity to be here to petition whoever has the power to do that, to change this image to something physically more accurate. If that happens, I would consider my contribution to LSST already significant. Other than that, I'm part of the DAS collaboration, which means that I'm interested in cosmology. Cosmology is the study of the universe as a whole and of our place therein. Throughout the ages, we've come up with many, many theories. Some make perfect direct sense. Some are beautifully poetic. And in the last decades, we've come together with this strange construct where the universe is a geometry that's expanding and composed by 70% of dark energy. Dark is the technical word we use when we have no clue about what it is about. 30% is matter, and the rest, between the 70% and 30%, is stuff, us. So that's our place in this model. And we describe it using esoteric language that takes years to master, an example of which is down there. More precisely, I'm interested in observing supernovae. So type 1a supernova are exploding stars that are as bright as a galaxy. Their light comes from the recess of the universe up down to you, and we name them with beautiful poetic names like Ascent 2011 FE. Anyhow, I've been involved in many parts of this music, from observing to calibrating the data, and those days I'm mostly interested in figuring out how the atmosphere changes the light and prevents us from getting the light directly of those stars. But the reason I'm here, the reason why I said yes to Gail, who is probably around here trying to run away. Anyway, the reason why I said yes to be here is because I get to tell you about the most exciting thing for me in LSST these days. So after long, long and difficult work, commissioning is afoot. What it means is that finally, all this work that has been done throughout the years is getting together, and the auxiliary telescope will be the first instance of that. And I'm really getting involved into many parts of it because I think that's great. Finally, we have the first instance of using the camera on site, using the software, and bringing together all the people with different opinions into getting to observe the sky with the thing we've built, analyze it, and actually make science out of it. So this is a complicated brew that will need some steering, but I think it's really exciting. And so thank you for getting me here and allowing me to say that. And to conclude, well, we're not organized yet as the mighty Roman legions with only one goal and a strong faith in the three manifestations of Mars. But still, for me, we're working really hand in hand now in getting something concrete happening. And so it might not be like this, but we still have a concrete, direct goal. And I've been asked recently to fill in a census, trying to figure out how the different bits of my work in LSST match and apply. I think the answer is much simpler than that. It's lots of fun, and just count me in. So thank you.
Thank you very much. I looked at the slides before the talk, and I wasn't entirely sure what that whole telescope on fire gag was going to be. Next up, we have a member of my team. This is Claudia Arrea.
Okay. So I'm Claudia Araya. I'm the EPO Chile coordinator. And first thing I should tell you, I'm from Chile, born and raised in Santiago. I studied astronomy. I got a bachelor's degree at Universidad Católica. And then I came to the US, where I got my master's degree at The Ohio State University. After that, I went back home. I wanted to try something different. So with no previous experience, I decided to start teaching math in middle school and high school. It was a little bit scary, but I ended up being pretty good at it, and I liked it a lot. So while still working there, I went back to school, and I got a bachelor's degree in education. When I'm not working or studying, I like to do crafts, all sort of things. I like to let my creativity flow and to experiment with new techniques and new materials. So those are two examples of things that I've done. I like to do mosaics. I love playing with shapes and colors. And I also like to knit and crochet and weave. And that's a wedding dress that I gladly and proudly made for one of my closest friends a few years ago. And I also love cats. So these three elements have been key for me for a couple of years, and they're key when describing who I am. And what happened slowly through the years is that these three things start to tangle and start to complement each other. So I found myself being inspired by astronomy, sometimes very on purpose and sometimes not. And I also got the chance to start teaching some of the techniques and the crafts that I do. So I got the opportunity to teach knitting and weaving both for adults and children at a community center for a couple of years. But in those instances, I was only able to combine two of these elements. I was never able to combine all the three of them until I came here to work for LSST. So what do I do? Officially, I am in charge of coordinating all aspects of the EPO program in Chile, and most importantly, for the Chilean community. So that means a lot of different things. I joined the team in February, so for this past 6 months, I've been doing different things. I've been having a lot of meetings in Chile, learning from different EPO groups and what they're doing there, building relationships with government institutions and with science centers. So I had the chance to visit the planetarium in Santiago and see the amazing behind the scenes of what they do there. I went to the MIM Science Museum and learned about how they design the incredible astronomy exhibit that they opened earlier this year. So that's what I've been doing with the people in Chile. In the meantime, I've been working also very closely with other members of the EPO team, and with them, we've been creating materials for teachers, activities for the classroom, support materials for the teachers to implement these activities, videos to motivate students. We've been planning evaluations on how to assess the needs of the Chilean community and of the Chilean teachers to make sure we include those needs in the design of our program. Lately, I've been starting to work on translations and mainly defining the best strategy and the best way of tackling this. One of the things I'm most excited about our program is that all materials and everything will be available both in English and Spanish. I'm the only member of the EPO team that's based in Chile, so that means that I've been traveling to Tucson very frequently. That's a picture of the botanical gardens. I love that place, it's so pretty. But that also means that I spend a lot of time on Blue Jeans, working with everybody from the team that's here. As we move forward with the program and with the designing stages, what I do will change constantly. But all of those things that I do and things that I start to do will always be around those three elements that I mentioned at the beginning, which is my love and passion for astronomy and for education, and my constant desire to create new things, to try new things, and always with the final purpose of make our best to bring the LSST data not just for the science community, but for everybody. Thank you.
She mentions to us in passing one time, oh yeah, I made a wedding dress for my friend, and then showed us that photo. That's a pretty incredible skill. Oh, clicker. Yeah, thanks. So next up, we have Michelle Butler from NCSA.
Hi, I'm Michelle Butler. I usually try to stay very far behind the sidelines, and nobody knows what I do or where I'm at. So this is weird to be out in front of everybody, so sorry if I screw up here. Yeah, I'm from NCSA. I'm a computer engineer, storage architect. That's my training. I graduated from college with my bachelor's a really, really, really long time ago. Sometimes it feels like we actually wrote our code on cave walls, but looking at what the kids are doing today. I started out from school writing COBOL programs and running CICS applications, which was what we used to do for Jupyter notebooks, is kind of what the thing is today. Trying to do that translation. I started at NCSA in 1990, so I've been there for 28 years, learning something new just about every day still, so that's why I'm still very interested in NCSA. I started out doing the mass storage system, which was an MVS IBM machine, and that probably is foreign language to you guys. So 28 years later, many changes. I started out as a storage admin. I went to the storage team lead, went to the storage group manager, and then I was the storage architect at NCSA, one of the architects for the blue water system that's currently running there. What do I do? Of course, I work at NCSA, which is at the University of Illinois. I am the LSST product owner. I have a co-host in crime, Margaret Gelman. I'm not where she is, but I'm a co-lead of the LSST project now. So I've left the storage team, and I'm now dedicated to the LSS team to bring the system in as it goes. That is a picture of our computer room floor and the LSST equipment on the floor, because we have quite a bit of pieces of equipment these days on the LC. What is my day like? This is what I was asked to answer. First of all, I check all of the stuff on that web page, but I was told that they don't like to do live demos, so the next page will have all those things on there, hopefully. Yep, there it is. So those are all the machine environments that we're currently running. They are not the environments that make those machines run, but that's what's all available to all the developers, from the Chile systems, the batch clusters, the Oracle consolidated databases, on and on and on. So if you're interested in looking at all the stuff that we're running or environments you can go use, that list is there on that URL. So what do I do? We have steering committees that talk about every single one of those platforms and what those environments are doing and where we're going with those. There's batch processing. There's the level 1 test stand that we have at NCSA. Jim Parsons and Felipe run that environment. Data backbone, the PDAC, that's the QServe environment and the Kubernetes environment. LSST dev systems monitoring, we got to procure everything on an annual basis. Service management, how do we keep all those going and make sure that I know about any problems that are going on those and how we resolve them. All the reports that were handed into LSST that we all love, right? Everyone loves the reports. LSST management meetings, so that I have to tell my uppers folks what's going on and that we make sure that we've got a direction going for the whole team. Where are we going next and how do we get there? That's what my life is like. The last slide was what keeps me up at night. So this is just a oh, that doesn't have everything on there. That is a map of South America and where the networks start and how the data gets up to, is that? No, it just isn't showing. Sorry about that. So that is a map of the networks of how all the data is going to come out of Chile and land in Miami, and then Miami up to NCSA. But what keeps me up at night is we have the summit down to the base to NCSA, and all the processing we have to do at NCSA. We send data back to the base. We're sending data to France for further processing. And then how are we going to get all this data out to the bulk data institutions, to all the alerts taken care of, and then, of course, our friends at EPO. That's what keeps me up at night. All right, I think that's last of me. Yes?
Well, thank you very much for thinking about all that.
I got it.
Yep.
Thank you.
And finally, on our Lightning Stories, we have a special presentation from Bill Schoening, who is winding down his time with Aura, and wow, what he's accomplished during that time. So, Bill.
I'm one of the designers for LSST, and I thought I'd give you a little bit of history of myself, and also it's going to be a little bit of history about some of the imaging that's changed over the years at the National Observatory. Come on. For some of you that may realize it, I'm sure now that I've been here for 50 years working for Aura here in Tucson, and I started in 1968. It's brought in here to head and start a photographic research lab. At that time, photography was basically all there was on the mountain for collecting data except for photometry. So that was widespread use for quite a long time, and the 4-meter was also just under construction at that time. And it became one of the most photographically used telescopes during its day. And during its commissioning, as we call it, I spent a lot of time up there exposing images. And these images, one of them, one night I ran a substitute color film in there from Eastman Kodak, and this was the result of it. This is a 45-minute exposure, and it was taken at the prime focus of the 4-meter. And at that time, we had no computers on the telescope. It was all manually guided. Everything we had to sit there and calculate from a sidereal clock to set the telescope. And then Art Hoag, who was the director of the associate director of the Stellar division, and I spent a number of nights taking photographs with a telescope. And this one I just kind of cheated and kind of threw in a piece of color film. This ended up on the front cover of National Geographic in 1974. And later, as CCDs became more relevant, they began taking over all of the photographic work that was done on the mountaintop. And I began working with the CCDs, and I started a lot of observers on the telescopes up there. In fact, there are probably a few of you out there who I worked with as undergraduates, graduates, and later as you got your PhDs, helping you get your data on Kit Peak with some of the different instruments up there. One of the instruments we had was the Mosaic Instrument, which is on the back of the 36-inch telescope. It was one of our largest CCDs for quite a long time. It was used on both the prime focus and the 36-inch, and it was in use up to just a few years ago. We also put a CCD on the side of a Schmidt telescope for the very first time that had ever been done, and it went from the most undersubscribed telescope to the most oversubscribed telescope. And in around 2000, I was approached to do an instrument for the Wind telescope. And one of our engineers handed me a little program called SolidWorks and said I needed to learn this program and use it. So I started using SolidWorks, and we did the instrument, built it, and as a result, I ended up getting an offer to move to DKIST, which is now, or was at that time, the Advanced Technology Solar Telescope Project. And I worked on that till about 2006. And at that particular time, they got funded. And they decided they no longer needed any kind of designers, and there were only 2 of us doing all the design work for the conceptual designs on ATST. And they let us both go. And I'm sure a few of you can appreciate what that did, not having any designers of any kind. So I went ahead and one of the people that I was working with retired, and I went ahead and went to Victor, and Victor brought me into the project. And so I've been on LSST ever since. And that's just a shot of DKIST. And I've been working on every part of this project, from the building to the telescope, to the pier, to the lower enclosure, just about everything that you can possibly do on it. I've had some areas that I have worked on this thing. And because this is my 50th year, I have decided that it's probably time to retire. I'm going to probably go out in January of this year. And some of you do know that I have a rather large car collection. I have about 12 cars that I've restored. This is one of those cars that's been finished. This is, and if anybody's interested, that's the website up there on the car. That's one of the General Motors concept cars. It was built, and it's the only one in existence. I rebuilt, and it's been shown all over the country. So I've had a good time playing with this, and this is what I'll be doing when I retire. Probably not going to go out until January of this year. One thing I did want to do, because this will probably be my last all-hands meeting that I'm going to be attending, I want to give some special thanks to some people in here that I've worked with. First of all, Victor, I want to thank you very much for hiring me. It's been great. I have really enjoyed it. It's been fantastic. I can't believe I've gone from the 4-meter into this kind of a project. So thank you very much. Also, I want to thank Doug Neal. Doug, it's been great working with you. I don't know where you are out there, but I want to thank you for everything you've done. It's been great working with you. I've learned a lot from you. You've kept me on the straight and narrow and helped me out a great deal, so I sure appreciate all you've done for me. So thank you very much. And the other person I want to recognize is John Andrew. John, it's been great working with you. It's been fantastic. You've always been there. You've helped me out. You've bailed me out of a lot of project problems that I've created and some that created all by themselves. I sure appreciated it. You've always been there, and you're a great asset to this group. I really appreciate all you've done for me. And all of the Telescope and Site group, everybody, Bill Gresser, everybody who I've worked with, it's been just great. I've really, really enjoyed it. I'm going to be around a few more months, so you're not going to get rid of me yet, so I'll be kind of watching over everybody and going on. But keep going on the project. There's going to be some interesting challenges. I know with Chuck over there, when you start getting this thing running, I know what we went through on the 4-meter, you're going to find some things you wouldn't even dream of that are going to give you some interesting problems. So just be ready for them. But this group can handle it, get it running, and get it working. I want to see this thing operational. Thank you.
Awesome. And so I'd just like to thank all of our speakers. I think I've got everybody's name up here. Thank you very much for coming up and sharing your stories with us. And so we have one more thing to talk to you about, which is Lightening Stories, trying to, just one more time, give you some idea of what it is and how you can participate. And we're going to highlight Victor yet again. Oh,
I'm good. All right. So my name is Kristen Metzger, and I am the science writer for EPO and Communications at LSST. And I am here this morning to tell you a little bit about Storytime Domain, which hopefully you've at least heard of by now. We've been mentioning it rather cryptically. But this is your opportunity to tell your story, much like the lightning talks we just saw. Pretty much everyone in this room has their own little piece of LSST to talk about. So we want to invite you to sit down with us and talk about that a little bit. So before I go any further, I will tell you that everything that I'm about to say and more can be found at the Storytime Domain link, which is on the Project and Community Workshop agenda page. So if you go to that page, go to your agenda, click on the Storytime Domain link on the right-hand side, you will see information about what we're doing, why we're doing it, and there's a list of prompt questions there which you can use to prepare yourself a little bit if you'd like to think about what types of things you do for LSST, what you're excited about, the types of things that some of our lightning speakers were talking about. I'd also like to extend a formal invitation to all of the lightning speakers today to come and chat with us since you're prepared anyway. But you don't have to be prepared. You can just show up. Emily and I will be in Agave 3, which is out in the main foyer. If you're looking at the travel desk where Erin Carlson is sitting, it's the room just to the left of that. Emily and I will be there today and tomorrow, and We will be available to get you on camera and record your story. If you want to come in with your own story and talk to us about it, that's great. Otherwise, we'll ask you a few questions and have a conversation and kind of see where it goes. There are a lot of different people working on LSST, and everyone is doing something important, and not everybody has the opportunity to talk about it. So we really want to highlight the diversity of the team and all the important work that people are doing. And we want to help inspire the next generation of astronomers and engineers and data management experts. And we think you can help us do that. So we're hoping to use this video to really fill out our EPO website, as Amanda was talking about, and kind of put human people behind a lot of the concepts that we're going to be presenting on that website. So there is a Google sign-up sheet that is also accessible from that link, the Storytime domain link. And I encourage you to take a look at that sign-up sheet. We've got 15-minute slots blocked. I'd like to say that Emily and I will be there all day today and all day tomorrow, but we do have a few conflicts, so the Google sheet will give you an idea of when those are. But please do stop by if you have questions, if you want more information about it. We'd love to chat with you. Also, for anybody who is interested in giving their talk or doing their story in Spanish, Claudia, who you just met, will be available in the later afternoons on both days. So if you're able to do yours in Spanish and want to, we'd love to have you participate. Just stop by and check with us, and we'll make sure you come by at a time where Claudia will be there to assist with translation and asking questions in Spanish. So again, I'd like to encourage everyone to participate. You don't have to be super comfortable speaking on camera. We'll make it as non-intimidating as possible. But come by with your questions and to talk with us more about it, and I hope to chat with a lot of you over the next 2 days. Thanks.
And that's all we have this morning. So enjoy your coffee. Thanks for your patience. Thanks for your time, and we'll see you later.